Right. Thank you, Will. I hope you guys are sharing my screen. Good morning, everyone, or good afternoon, wherever you are in the world right now. It's my pleasure to be here with you today to talk about integrating narratives and visuals to help you communicate your data more effectively. So in this session, my goal is not only to share with you some basic principles and tools on how you can communicate your data or your work more effectively, but more importantly, I want to impart with you and share some insights on why is it important in developing environmental intelligence and environmental problem solving. And I'll start this presentation by sharing my own personal and professional experience and how I became very passionate about science communication and stakeholder engagement. And we'll also introduce our group, the Integration and Application Network, which is a small organization that is part of the University of Maryland Center for Environmental Science. So I am originally from the Philippines. I started my career in basic science and research. I've always been passionate about the environment. I was a marine scientist working on harmful algal blooms and microbial communities. I've always believed that more science, maybe from more technology, more research, will be able to solve environmental problems. But then when I moved to the US, we do have the same issues here. And it's not always about the technology or the lack thereof. The biggest commonality is the lack of effective science communication and integration. And this idea is really enforced by the fact that environmental problems are social issues and that everything is connected. And what becomes really important is managing boundaries, which could be sectoral, organizational, or geographical boundaries, while creating information that is salient, credible, and legitimate. What is needed are communication strategies that are stakeholder-driven and consider both scientific information and the human perspective. One such tools are report cards. That's what we do to integrate data at the Integration Application Network, such as this Laguna Debate Ecosystem Health Report Card that is actually funded through a project funded by the UNDP that I helped develop as part of the Integration and Application Network, or IAN. I've been with IAN now in various capacities for nearly 7 years, and we've been referred to as boundary-spanning organizations. We specialize in science communication and synthesis, social environmental report card development, stakeholder engagement, capacity building, and training. We also teach professional and graduate courses. One of my ongoing projects is the development of massive open online courses. So we offer a professional certificate course in the edX platform. The good thing about MOOCs is that all of these courses are free to audit and they are all self-paced. So if you're interested in learning more about communication and storytelling with data, you can go into the edX platform and take these courses for free. So our group's motto is to communicate better to empower change. And we advocate that through the development of environmental intelligence, which we define as the ability to acquire and apply environmental knowledge. The key to our application of the term is that it is the collective understanding that the community shares about the environment. We can visualize environmental intelligence in the form of a pyramid. At the base of this pyramid is the data gathering, which you've all been doing. And the next layer is information gathering. This is where synthesis and integration efforts are done to convert data into usable information. The next layer is knowledge building, which is facilitated by science communication through conceptual diagrams and data visualization techniques, which I will share and touch on in this presentation.
Yeah, I'm listening. Sorry, let me make sure.
Sorry, okay. At the top of this pyramid is communicating good science effectively in a timely manner is what creates this environmental intelligence. So putting together this pyramid, you can see that the degree of information synthesis occurs with each increasing layer. And in order to achieve broad community knowledge, this communication needs to extend beyond the scientific literature or technical reports to be more accessible. Example of this is the environmental report cards that I've mentioned earlier that synthesize and integrate data and communicates it in a meaningful way. So it has been used increasingly globally, and here are just some of the examples of report cards that we at IAN help develop all over the world. And report cards do increase environmental intelligence. From my research, report card practitioners strongly agreed that their report card increased public awareness, public education, political awareness, and demand for additional information. But report cards are more than a science communication product. The process of developing them is a great tool for stakeholder engagement and social environmental synthesis. If we take a social environmental system, which we are all a part of, we have the resource system and a governance system, and they interact in this focal action situation. We need to consider both the environment or the natural world, but we also need to consider the social system or the human dimension. And more importantly, we need stakeholder input. And the key principle that is needed to pull all this together is communication and engagement. Currently, my interest in social environmental problem solving through teaching and capacity building, which I already mentioned previously, and social environmental governance, where I'm coordinating a project that involves the US, Philippines, Norway, India, and Japan. For the goal of social environmental problem solving, which I know that we all share, both science communication and stakeholder engagement is needed. The degree of stakeholder interaction depends on the complexity of issues, but what is consistently needed in all these types of engagement, be it outreach, collaboration, or co-production, is effective science communication. And I've been talking about science communication, but what is it really? If you look up the Wikipedia definition of it, it is the practice of informing, educating, sharing, the wonderment in raising awareness of science-related topics. According to Burns in a research published in 2003, it is the use of appropriate skills, media, activities, and dialogues to produce awareness, enjoyment, interest, opinion forming, and or understanding of science. At IAN, we have a more functional definition, which is simply the successful dissemination of knowledge with a wide range of audience. And the most important goal in communicating science is simply effectiveness. And to achieve this, we have to first ask ourselves, who are we communicating with? Who are our audience, our stakeholders? This is very important. This is very important because even though the data and the monitoring results are the same, how you communicate them can vary depending on your audience. So when designing our communication strategies, it is very important that we stop asking ourselves, what do I want to say? And start asking ourselves, what do I need my audience to learn? And we can convey this information more effectively by using stories and visualizations. Humans have been telling stories before the written words, and ancient people drew pictures as far back as 40,000 years ago. And it's not only that storytelling and visualizations are the most ancient forms of human communication, but our brains are actually hardwired to respond to stories and to visualizations. Effective science communication taps into the limbic system or our emotional brain, which affects our emotion, behavior, motivation, long-term memory, and it also affects the neocortex or our thinking brain, which is related to our sensory perception, cognition, spatial reasoning, and language. It is also important for us to think about and differentiate between the why and the what. Why addresses motivation and emotional content, And it goes to long-term memory. The what question addresses cognitive and rational basis for an argument. So both of these questions are important to address when we communicate. So with this knowledge in mind, ask yourself, who are you communicating with? So I would like you to share your answer with us by using the link that I will put on the link on the chat. And if you are using another device, such as your cell phone or iPad, go to a browser and go to menti.com and use the code 2386 and 1315. So you should be able to see this question, who are you communicating with? Please use 1 to 2 words. Right, so we have stakeholders, public, supervisors, so far politicians, citizens, civil society, lawyers, that's a very specific one, decision makers, ministers. You can see that they're very diverse type of audience, and it's very challenging to create a communication strategy that can communicate with these different stakeholders. So it's great that one of the most common answers here is public decision makers and researchers. So in investigator, public institution clients, students, that's a good one as well. Civil society. So the top 3 answers, it seems, are stakeholders, the public, and decision makers. So I will move on. So thank you so much for the answers. I will move on to the next question, which is, so just please go to the next slide if you're using your device. The next question is, what do your audience need to learn? So this is a short answer type of question. So a sentence would be, or a phrase would suffice. So think about, what do your audience need to learn? So we have investment priorities, good. Reliable data, that's very important. And I guess communicating them more effectively would really lend itself to that. How to prioritize available funds, indicators, data, ecosystem health and climate solutions. I assume it's quality of data. And inequality distributions, how it benefits them, it's very important. The why question, what data are actually available, so identifying what data are available and also knowledge gaps. Inversion, different water scenarios, clear definitions, gaps, I mentioned, water availability and service quality, how problems could be solved, that's very important to think about as well, how these are useful to them, and employment level, status, and change of issues. So great, thank you for your answers. Water quality services, thanks. And so thank you for all your participation. We have 2 or 3 more Menti activities, so please keep it open. Summarizing some of the science communication basics. First, science communication is the successful dissemination of knowledge to a wide range of audience. Second, the goal is effectiveness. Third, we need to ask ourselves, what do I need my audience to learn, not what I need to tell them? And finally, our human brains are hardwired for visuals, and the why and what affects our emotional brain and thinking brain, respectively. So as I mentioned previously, stories are powerful communication device. They are also more engaging and interesting than a string of facts. So in using narratives in science communication, I will share some basic principles. First, context is key. Address why your audience should care. I mentioned that effective science communication taps into the limbic system and the neocortex, and we need to address both the what and the why question. However, as scientists and technical experts, we often start with the what, then the how, and the why, which may not always be effective. Ideally, we should go the other way. And the primacy of addressing the why question is that it gets to the limbic brain where our emotion and behavioral aspects are controlled. And the what question gets to the neocortex or our analytical brain. So going more into this manner is more effective. Second, active titles can help guide the audience and link with visuals. Active titles are short declarative statements that summarize key messages. If written effectively, the audience should only need to read the active title and the rest of the slide to understand the primary message. Verbs that describe the results of a graph, map, or picture are typically used. In the example here, in the second example below, seagrass and sediment characteristics were recorded is far more informative than just saying methods as the title of your slide or your presentation. Ultimately, combining active titles with strong visual elements lead to a more persuasive science communication product. Third, I want to talk about a narrative structure that we like to teach, and this is the ABT structure. So this is popularized by Randy Olson, who is a scientist and filmmaker, who has published two important books on narrative structure, which is Houston, We Have a Narrative, Why Science Needs Story, published. He defined three kinds of narrative: the AAA narrative structure, which is a series of statements linked by end, which can be boring and a repetitive way of speaking. The DHY structure, or despite, however, yet narrative structure, can become very confusing and overly narrative. So the preferred structure is the and but therefore, which leads itself more to a narrative. The ABT structure provides agreement using the end, which is the setup that we can all agree on, the contradiction or the but, which is the problem, what we are confronting, and finally, the consequences, the therefore, which are the actions that are being taken or could be the solution itself. This is an example of the use of an ABT structure to describe one of the projects funded by the Belmont Forum to address coastal vulnerability. So you can see the opening sentence starts with a description of the risk level of megacities globally. The project is about assessing vulnerability in coastal megacities. So they start the statement with the description of that and followed it up with a problem that the risk managers in this city faces. And then they conclude the statement with a statement on how their project is addressing the issue. Another example is this statement describing the proximity to water treatment plant as a potential environmental justice indicator that is written by one of my students in a class that I taught the previous semester. She started the statement by describing what water treatment plants are and followed it up with different ways on how they can be harmful and how they tend to be located near marginalized communities. And then she ended the statement here with a therefore on why this indicator could be, on how they could be used for environmental justice. So the next principle is that storytelling can be powerful tools, and they can be powerful science communication device for three reasons. First, they engage the audiences far more, they engage the audience and they're far more interesting than the string of facts. They improve retention because they're easy to remember. And finally, they shorten the reading time to audience. A reader can quickly and easily follow a storyline with more effective comprehension. So what makes a good story? One thing that makes a good story is causality. We need to establish a cause and effect relationship. Another key element in a story is temporality, which is having a timeline with a beginning, a middle, and the end. The other thing that good stories share is that they have people involved. The problem with science and how we communicate them is that we often just focus on the data and the facts, and we leave out the people part. Finally, stories need to be more relevant to the audience. And so this is how involving the people more can really connect with your audience. So it's really important that your story makes a connection to your audience. So the hero is a common template of stories, and a lot of storylines in movie follow this hero's journey, where it involves a hero who goes on an adventure and is victorious in a decisive crisis and comes home changed or transformed. The process of creating a story out of scientific materials required that scientists distill information into a product that has a message, a story that is easy to follow, well organized, speaks to the values of the audience, and is pleasurable experience. In other words, stories can make science accessible. One effective tool to organize effective science communication is called the message box. A workbook is available online from the Compass Science Communication group that can guide you through this process. So just quickly, so if you follow this message box, you can basically make a story out of your research. So inside, you can describe the issue that you're focusing on, starting in, and then going out to the top, you list the problems. What are your findings that makes you want to communicate and why it affects people? Moving clockwise, briefly answer the so what question. What does your audience value? How are they impacted? Why should they care? And why is it that you are communicating important to them? At the bottom, list the potential solutions. What changes can be made and by whom, and how it would solve the problem. Finally, to the left, list all the benefits from the solutions, both short-term and long-term. Finally, we all know this, and just simply that we need to simplify our communication and define terms. It's easily said than done, but we need to avoid jargon, but we don't necessarily have to dumb it down, but instead raise the bar. So it is harder to simplify your research, your data without, we think, distilling the information and removing relevant information. So simplifying things actually is harder because you really need to think about what you wanted to tell your audience. All right, so again, okay, so we move to an activity. So if you may please go to back to Menti, and I will put the link into the chat, and we'll do a little ABT exercise. So I'll start the statement with the end, and please provide the but or the challenges. Increasing wastewater treatment and improving water sanitation is important, but so if you can identify challenges and list them down on the Mentimeter in 2 to 3 words. right? So we have here financial constraints. They're very costly, and it's not a political priority. There's a lot of challenges such as antimicrobial resistance. When we need quality data to do that, there's also climate change. Funding is expensive, data gaps, right? Collaboration is needed, more understanding, and it could be undesirable. So as you can see on that statement by my student about how it can actually affect if you live near wastewater treatment plants, the health of communities. All right, so thank you all for your participation. Again, to summarize the section on using narratives in science communication, remember, context is key. We should address the why question, why your audience should care. Using active titles can help guide the audience and link to visuals. Narrative structure should follow the ABT template. Storytelling using cause and effect, timeline, and people can be a powerful tool. And simplify and define terms, avoid jargon, scientific jargons, but do not dumb it down. Instead, raise the bar. So next, using visual in science communication can be very effective because as humans, we are visual creatures. So here are some examples. Here are some principles in using visuals in our science communication. First, there is a diversity of visual elements that we can use for science communication. But remember that developing them deserve as much time and effort as developing your text. Some of the commonly used visuals are photographs, maps, and graphs. The key here, though, and it goes for all visual elements, is that we have to make sure that you have the proper attribution before using them, that you can actually use them in your report, in your presentation. At EN, what we commonly use are symbols, which are easily recognized and information rich. We have an EN symbols library that is free to download from our website. And we like symbols because symbols are language independent and they are universal. They can also represent something tangible, like a book or a building, and also something invisible, like the wind, or intangible things like emotions. Nowadays, in our daily life, we even use icons or emojis to communicate. Another form of visual element is a conceptual diagram, which is a thought drawing that can be used to communicate complicated processes and environmental concepts in a simple and easy to digest format. For example, this is a conceptual diagram illustrating a modern central collection and waste treatment plant. It is easily understandable even for non-engineers or scientists. And this is also where we use the use of symbols can be very helpful. So videos are another form of visuals, and they are great because they can convey a lot of information in a short amount of time, and you can reuse them too. So I will reuse a short clip from our online science communication course to explain the third principle in using visuals, which is eliminating extraneous information or chart junk. So I'll just have to make sure that I'm sharing this sound. Okay, good.
I want to talk about chart junk, which can be defined as all visual elements in charts or graphs that are not necessary to comprehend the information represented on the graph, and that distract the viewer from this information. I'll go through an example of a science visualization that has a lot of chart junk and how removing extraneous information can help make the visualization more effective. Starting out, a spreadsheet output of a bar chart with monthly rainfall is produced. A series of questions are posed. Is the background color necessary? If not, you can remove it. Second, are the grid lines necessary? If not, take them out. Are tick marks on the axes important? Tick marks are often important, but in this graph, the month is written below each bar, so the tick marks don't really add any value. Does a legend provide additional information? The legend only duplicates the labels on the x-axis, thus it's redundant. And since the graph provides the values, do they need to be written out? The viewer can read across the row to determine the value of the y-axis without the need of writing that figure down. And the border around the graph, is that necessary? The axes are crucial, but putting the whole graphic into a box isn't needed. So using these questions as a guide, this graphic can be significantly decluttered and improved.
All right, so the next principle is to take into consideration our cognitive response to visuals. There are many aspects of a visual element, but for now, I'll just talk more specifically about colors. For instance, in this graphic, we use the universal stoplight color of red to stop, orange to wait, and green to go to indicate increasing risk. So notice the varying levels of red. Of course, there are other considerations such as color blindness that we have to think about as well in using colors in our science communication. The next principle is that making our visual as self-contained as possible, like this conceptual diagram, where the symbols are embedded in the caption, is preferred. You don't need to read the entire text or find the description in the text to understand what this diagram is actually saying. Lastly, visuals need to be fully integrated with the text. In developing science communication products, we want to be as concise as possible. No matter how good a visual element is, if it doesn't add to your story, then it's just another form of clutter. So we have to make sure that whatever visual you add, you refer that back in your text. Otherwise, just don't include it. So let's go back to the Menti, and I have a question here on what are the challenges in incorporating visuals. So again, this is a short answer type of question. So if you can think about what are the challenges in incorporating visuals and share it with us. And if you don't have access to Menti, and I'm sorry I forgot to mention this, but please don't hesitate to put them on the chat and I can include them for you. So I'll give it a few minutes for answers to pop in. So the first one here is takes loads of time. Yes, so I mentioned that in the beginning, is that we have to give them as much time thinking about it, developing them as when we write our text. Expressing the right message is very time consuming to generate. Yes, technical knowledge, having reliable data, access to software. That's also a challenge that we found working with other groups. Sometimes we use proprietary softwares that not everyone has access to. Color blindness, yes, that's also a very important consideration. Accessibility requires good design. Yeah, design is, you can't just pick some random design. It has to really contribute to your story as well. Being able to visuals to be simple but effective, needs external expertise to do it well. In the next segment, I'll show a video on how you can do it as well, even in just as simply as Excel, thinking about cleaning up your graphs. And necessitating someone who does it. Yeah, so editing document is not a field of expertise for scientists. We have to learn this. That's a lot too. In our group, we all have scientific science background that learn science communication, because we found that it's easier that way instead of graphic artists learning science, scientists learning how to do it is actually more effective because you know your material. So you know the best way on how you can communicate and explain them. Image rights, that's very important. Grabbing photos from the internet doesn't work. So you have to make sure that we have the rights to use images. Yep. All right, so thank you. Thank you all. And again, just to quickly summarize the use of visuals in science communication. Diversity of visual elements enhances science communication. Eliminating extraneous information or chart junk or map clutter is important. Cognitive response to visual is an important consideration. Self-contained visuals with supporting information are preferred. And finally, visuals need to be fully integrated with the text. So in the next few slides, I will talk about specific tools that you can use in communicating your data. First is data visualization. And I will again play a short clip about some important consideration in data visualization.
The goal and rationale for data visualization is to communicate information both clearly and efficiently. You can use a variety of different graphs and plots and information graphs and tables and charts and maps to communicate information. An effective visualization helps you uncover trends, realize insights, explore sources, and ultimately tell stories. Effective science communication using visualization can make complex data more accessible, more understandable, and ultimately more usable. There are a myriad of choices for data visualization. There are XY graphs and tables and pie charts and bar graphs and Venn diagrams and timelines and scatter plots, bubble diagrams, histograms, area charts, and more. There are combinations of data graphs with maps and with conceptual diagrams and with photographs. The real challenge is to choose the appropriate visualization for the data that you're communicating. Good data visualization combines function and form. In terms of function, this is about choosing the visualization type that best conveys the characteristics of the data. Then the form is when you apply color and choose your fonts and other design elements to help guide the user to help make your data understandable. Here are some examples. 1. The functional output is a bar graph of some responses to treatments, and the form is applied to simplify the color scheme, match the color intensities to the treatment temperature, and declutter the graphics, adding an active title and a symbol of the species being assessed. Second example is a functional output of an XY graph, seasonality of 2 different seagrasses. The form is when you add the colors and symbols, increase the font size of the legends, and include an active title. Third example is a pie chart of land use, initially generated with different land use types that are kind of obfuscated because it's obliquely angled. It's colorful, but it doesn't give you information. So rather a bar graph with actual percentages of land uses are displayed. 4, tables also need careful formatting and attention to detail. A table with several treatments over a time course doesn't provide much information without significant accompanying explanation. So what you can do is create better descriptions, defining the error bars, using alignment rather than color banding, creating a table that has much more explanatory power. It's cleaner and it's easier to read. From these examples, you can see that combining function and form leads to a better data visualization graphic. Most data visualizations are created using an iterative process. You can start out with a simple printout of a data table that comes from a spreadsheet. This table without any formatting is difficult to interpret. Some simple formatting by centering the data in the column headers helps, but what really makes this table work is when it's decluttered by removing all vertical lines and most of the horizontal lines, and allowing the alignment to serve as guides to the rows and columns. The locations are spelled out, and instead of using abbreviations, use a symbol for each organism to make it easy to quickly understand what it is. That resulting table is more compelling and more self-explanatory than the initial spreadsheet-generated version.
So visualizations can also be an effective way to communicate or present qualitative data. In this example, I created a visualization of what a sustainable future Chesapeake Bay should look like based on interviews with key stakeholders. Note the use of active statements and images to convey specific key points. I also use animation to present the results because I'm showing this as a part of a presentation, and it's more effective that it shows as a build instead of just giving it to you one by one. So quickly, I will talk about science communication products as like data visualization types of graphs. There are a variety of them, but I will only talk and show a few examples. So first are posters. The advantage of posters is that they can potentially reach a large audience. They can remain displayed for a longer period of time. But some of the challenges are that they are expensive to print, they could be difficult to transport, and they're also time intensive. A second commonly used ones are newsletters and fact sheets. Advantages are they could be quick to produce and they're easy for a broad audience to consume. Some of the challenges is that they have limited space availability, so there's only so much you can put in there. It's the same with posters as well. And sometimes they can be viewed as marketing tools. So if you simplify things too much, it looks like some kind of marketing tool. Another example are report cards. And I already gave an overview of report cards in the beginning. And as I mentioned previously, they are effective communication tools because they can provide accessible and synthesized information to wider audiences. Following this information pyramid, and using the Mississippi River Watershed Report Card that we helped develop as an example, you can see that this report card is supported by primary data. We consulted and engaged with various experts, and we developed other products such as reports, newsletters, fact sheets that are all developed to support the report card. So we have a methods document that supported how we did develop the report card and did the calculations and everything like that. So the report card was able to synthesize different information from different sectors, such as the recreation, ecosystem, flood control, water supply, economy, and transportation. And we also were able to convene stakeholders from those different sectors. A number of them actually mentioned that this effort was actually the first time that they've been in the same room together. So that was very exciting to hear. And throughout the process, knowledge gaps were also identified. Report cards can also generate media attention. For example, the Chesapeake Bay Watershed Report Card. So I am here in Maryland, we're part of the Chesapeake Bay Watershed, and our university released report cards, the Chesapeake Bay Report Card, every year since 2006. And every time it was able to generate a lot of media attention. So the most recent one we released in June, and it generated 193 million media impressions just during the release event. Also during that event, we disseminated a newsletter, I showed it earlier as an example of ABT, on the Framework for Environmental Justice Index for the Chesapeake Bay, which is a product of a class that I co-taught early this year. And you can see that we use different visual elements. We have included short narratives. And in the indicator section, as I showed an example earlier, we specifically asked the students to use the ABT framework to develop the indicator description and ask them to think about accompanying visuals that can help them make their point. And after the release event, my co-instructor and I, along with one of our students, were invited by our state senator in the state of Maryland to talk about the report card in his Facebook Live event. Various news articles were also written about the report card results. And I'm showing this to show an example on how developing effective science communication products could be able to help you reach your target audience. It can potentially be disseminated further using social and traditional media. So this will be the last mentee activity. And what kind of data visualization or science communication product are you or will be using specifically to inform policy? I know you have a homework from Will earlier, so maybe that's something you could answer as well. Oh yeah, Prezi is a good way to make presentations. Conceptual maps, yeah, indicators. So how are we visualize your indicators? Important. Pictures, press release. That's also very common, especially by universities. Infographics, charts, basin profiles or maps, reports, presentations, web pages. I didn't mention that earlier, but it's part of the science communication product that also very popular now. Web page, data sheets, bulletins, animations that also very effective, such as it's like creating short clips or videos. You can put a lot of information in a short amount of time. Okay, so thank you for your participation. And I hope that the things that you learn in this workshop can help you in creating this data visualization or science communication products that you will be using in your country. So just to summarize some of the important points to remember, developing environmental intelligence and solving environmental problems requires effective communication and engagement. Second, science communication is defined as a successful dissemination of knowledge to a wide range of audience, including non-scientists or non-experts. Effective science communication uses storytelling, context, visualizations, and synthesis or integration. And finally, science communication could be done in a variety of ways. So with that, I will end my presentation. And if you want more information, you can email me directly. My email is here. You can go to our website, ian.amsis.edu. Like I mentioned, we have a variety of science communication products and we have symbols library, image library, and you can take this online course, the Strategic Communication for Sustainability Leaders, Storytelling with Data Using Social Environmental Report Cards, and Science Advisory Toolbox for Environmental Management are all live now. And you can take them at your own pace, they're all self-paced. You can take them, there are a lot of informational videos there. And I hope, and the last course in the case studies, we're actively developing that one, and it will be released in April, hopefully. So I can take some questions if we have questions, or appreciate any comments from you guys. Otherwise, there's no question, I can turn it over to Will, but we have a few minutes.
Thanks a lot, Vanessa. Yes, so we do have a few minutes.